Hello, everybody. My name is Jess Bowles, and I am the data scientist for the University of Belize's Environmental Research Institute. This is the first video in the free Introduction to RStudio series, where we go over the foundations of working in RStudio. This first class is on the absolute basics: objects, vectors, and math. In the future, we will discuss working with data, data transformations, creating visualizations using ggplot, custom functions, and way more. I hope you find this series useful, and feel free to reach out if you have any questions at all. The reference materials for this class may be found in the video description, such as a copy of the slides, a reference sheet, and my example code. All right, let's get started. R is a programming language / environment for statistical computing and graphics. It allows us to analyze and visualize our data. R provides a command line interface where code can be written and executed. It's free, open source, accessible, and is the growing standard across science. So I always encourage students in environmental resource management, in biology, in most fields of science to get a basic grasp on R and RStudio because it will help them in their careers. RStudio is a free integrated development environment, or an IDE, used in R, kind of like PyCharm for Python if you're familiar with how Python works. IDEs allow for a user-friendly interface that makes data analysis and programming much more convenient. The benefits of using RStudio as an IDE include being able to easily organize your code into projects, being able to more easily install packages from the internet, which expand the capacity that R has, and better visualizations and interface. For this series, we will be using both R and RStudio. You need both of those installed. If you're having trouble with doing this, please refer to the help document in the video description for an installation guide. Okay, now that we hopefully have everything installed and ready to go, let's try using R. So please open up R on your computers, not RStudio, and you should be seeing the console appear. I want you to try typing 1 + 1 in the console and pressing enter, just to get a basic idea of how this interface works. So as you can see, you can directly put in your commands into the R console to see results. 1 + 1, enter, it gives us 2. So we put in an input and we get an output. It's pretty basic. So let's now see how this works in RStudio. So please, I would like you to next open up RStudio. This is a picture of the RStudio interface. As you can see, the R console is included on the left side. I'm just gonna open my laser pointer here. Oh, that is not my laser pointer. There we go. So this is a picture of the RStudio interface, and here on the right, the left side is the R console. So this is what we just had open when we had R. And the global environment is on the top right, and this is where any objects, analyses, or visualizations will be stored. So R will remember anything that goes in this global environment. And in the bottom right, this is where our files, plots, and packages can be viewed. So we've got a lot more going on here instead of just the console, which is what R was running. So let's actually try RStudio. First thing we need to do is to create an R script by clicking the little paper with a green plus in the top left corner, that icon right there. So you should be able to select an R script, as it says here, and then we should save it and name it. For example, you could call it R Notes Week 1. And it should appear in the location you saved it with a .r file extension. And you can open and edit and save this script anytime that you want. So please go ahead and create an R script for this lesson. Save it and name it. Okay, so now that we have a script open, let's try writing in our script. Any of your own notes can be made in R with hashtags. Anything written with a hashtag will be ignored when running code, which is very nice. Here is an example. You should use this all the time. Hashtag new project, there's a title. I'm putting in my name, year, month, day, and then I'm putting little titles for each section. So basically when you do this, you can look back on the script anytime or when others look at it if you're sharing your script, and then you and they know what's going on. So please try it out. Just go through in your brand new script title it similarly to the example above. And you should be noticing by now that scripts work a lot more like a document than the R console, which we started in. Pressing enter adds a new line instead of running the command. To run a command like this 1+4 part here, you have to press either Control Enter or click the Run button in the top right of the script box. So please try titling your script like this and then running a little piece of code like 1+4. Just to give you an example here, at the top, I've typed 1+4 in R, and then below in the built-in R console, it gives the result, 5. And of course, there are many more math functions that we can do. Addition and subtraction can be done with the plus and minus signs, like 3 + 3 - 100 + 2.5. R can calculate that, no problem. You just type that in your R script, Control Enter or Run, and then it will calculate it for you and put it in the R console down below. Multiplication and division can be done with the asterisk and with the slash. So for example, 2 * 2 divided by 4, R can do that, no problem. To do exponentiation, we do the caret sign, the little hat. For example, 3 to the power of 2. To take the square root of something, we use the function sqrtx. So this is our first real function here. So I just want to take a little pause and acknowledge it. So what's happening is the function is on the outside, this sqrt, and then inside the brackets are all of the parameters that we need to put in. In this case, it's just an x, and this x is any number. So square root of 4 in our example. So R will take the square root of 4, but it could be any number value for x that it will take the square root of. So that's the nice thing about functions, is they can generalize to any value that fits the parameter requirements. To take the log of something, we can use another function, log, and this has 2 parameters, x, which is any number, and then base. And base is, of course, the base of the log calculation. If we want to, we don't even have to specify a base in this case. When you don't specify a base, R will automatically calculate the natural log, ln, and use base equals e. So in this example, I'm calculating the log of 8 in base 2. Finally, we can calculate absolute value with the function abs. And of course, again, same thing. Our first parameter is a number here. So we can calculate the absolute value of -11. Pretty straightforward. These are just some basic math functions. And I would love you guys to get a little bit of practice with this. So here are some tasks for you. So using all of this information on the left side that we just went over, please complete the tasks on the slide for practice. And if you need some time, just pause the video, do what you gotta do, practice it, debug it if you need to, and then you can continue the video when you're ready. And if you are getting stuck with any of the code that we're doing throughout the class, please refer to my example code in all of the reference materials, and you can see the solutions and little explanations for everything, just if you get stuck. But I definitely prefer that you try and do this by yourself. Okay, while we're talking about math, another great thing about R is that math functions respect order of operations in R. Now this is your PEMDAS, your BEDMAS, whatever you learned it as. So in the example down below, looks like a lot of numbers to me. So R is calculating the brackets first, then it does the multiplications, and then it adds. So it follows our BEDMAS or PEMDAS order of operations. Something to keep in mind. We can also ask logical questions of R, like, is 2 less than 4? 2 less than 4. In the example below, we're asking, is 7 less than 4 + 10? So again, using our order of operations, R is calculating 4 + 10 first, 14. Is 7 less than 14? Very nice. This little less than sign here is called a Boolean, or a logical operator. And there are tons of these logical operators in R. You may have encountered stuff like this in other cases, like when you're trying to do a really specific search query. but it does work a little bit different in R. So we're just going to go over those together. Most basic is, are these two things equal? That's where equals equals comes in. Equals equals asks are these two things equal? 2 equals equals 2 would return true. So a logical function always returns a true or a false. Is 2 equal to 2? True. Is 2 equal to 3? False. Exclamation point equals is the opposite. It asks are these things different? So 2 exclamation equals 2 would return false. We know about less than and more than signs already. We just covered that. So 2 less than 3 should return true, since 2 is in fact less than 3. Less than equals and more than equals ask if the value is less than or equal to the value or more than or equal to the value. For example, if we ask R whether 2 is less than or equal to 2, we should get true. Or is special. It is notated with this vertical bar here, which can sometimes be hard to find on your keyboard. Sometimes it shows up as 2 vertical lines right on top of each other. So definitely fiddle around on your keyboard or look it up if you can't find it on your specific keyboard type. But you do want this vertical bar here to show up in R. And that means or. So basically what it's doing is it's allowing us to work with multiple cases at once. We can ask, is 2 equal to 3 or is 1 equal to 1? Well, obviously one of those is false, 2 is not 3, but 1 is 1. So if we use or, R will look if either of those are true, it will return true. Because 1 is equal to 1, it will return true. If both these were false, it would return false. And works really similarly. It's notated with an ampersand, which is this funky curly and sign. But this time we're asking R if both things are true instead of just if one is true. For example, if we do the same thing as before, but with and instead of or, we get false because it needs both sides to be true. Yes, 1 is equal to 1, but 2 is not equal to 3. So it would return a false since it needs both to be true. Whereas or just needed one of them at least to be true. Okay, so now that we've seen all those operators, we're going to do the same thing. And here is a task for you. So I want you to please check if 2 plus 1 is equal to 3 and 3 is less than or equal to 4. So using what we just learned, give that a try. Please try and do the task. And if you get stuck, you can always check the reference code. So give that a go. And once you've done that, I have one more little challenge for you. And again, as a reminder, the challenge solutions are provided in my R code in the folder for this week, if you ever need to reference it. So your challenge is find out which value is greater than R. And when I'm saying which value is greater, think that's going to be either, we're going to be using our Boolean, so we're going to expect a true or false. So think about that when you're setting it up. So 1.2 to the power of 8, or the log of 102 in base 4. So give that a go. Okay, now let's talk about objects. Objects store our values, functions, data, figures, and they're all added into our global environment in the top right corner to store that information so R can remember things that you're telling it. For example, here I have cat underscore name set to Felix and dog name set to Shadow. I also have a list of numbers from 1 to 3, and I have the year as 2023. So these are all values that I manually added in as objects into the global environment. And of course, we are going to learn how to do that ourselves. You can name an object whatever you like, but no spaces or certain symbols because R needs to recognize it as a single object. You put the chosen name on the left, then a single equal sign, not 2, because remember 2 equal signs is asking R if they're equal. 1 equal sign is telling R that they're equal. So I'm telling R that my object is equal to 2.5. I'm assigning that value to that chosen name. And you should, when you do that, be seeing my object pop up in your global environment, like I showed here. So that my object should pop up as 2.5 in the global environment. Classes are a way of differentiating objects from each other. So R knows whether the object is a number, a word, or something else entirely. For example, numbers like 1, 2, 3, R would treat that very differently than characters like the word fun, or logicals like true or false. All of those are treated differently in R. So we need to make sure that R understands which class we want our object to be. Let's talk about creating objects for each of these classes. Creating a numeric is super easy. We just did it. All you do is write the name. So like my numeric is an example, but you can call it anything that you want. You can call it Stephen. You can call it 5.4 equals 5.4, anything, as long as you're putting it on the left-hand side, equals, and then putting the actual value of the number on the right. So it's very straightforward to create a numeric. And a numeric is just any number. Next, we have our integers. Integers are a lot like numerics, but they're only integers. They're only whole numbers. Because R automatically calls most numbers a numeric, when you're assigning the object name, you should add this function as.integer. So that way R knows that you want it to be an integer and not just any old numeric. And you might be wondering right about now, what on earth is the point? Why would I want it to be an integer when I could just call every number a numeric? Well, in some cases in science, it actually makes a lot of logical sense for things to be integers. For example, say you're only working with like the number of people in a household. Well, you can't have 5.4 people in a household. It has to be either 5 or 6. So in that case, you'd want to make sure that your numbers you're working with are integers, so R doesn't accidentally call things a point, a decimal value. Okay, moving on, we have our characters. Characters are a string of text. For example, the color purple, or the mailing address of your best friend, or a phone number, or a name, or the entire script of a movie that you like. We need to put quotations around the character so R knows to read it as a string of text. And you can put a lot of text in here as long as it's separated out by these quotation marks. And R will know that it's all supposed to be one string of text. So all I'm doing here is a simple, my color equals purple. Remember, this name can be anything. Logical classes are our true and false. We just worked on that for quite a while. If you type true or false, R will automatically class it as a logical. So that's pretty straightforward. We don't have to do any special functions or quotation marks or anything like that. Just all caps true or all caps false. The function class is very handy, and it tells you which class the object is, where X is the object. So going back here, if we made lucky equals true, and then we did class, and then in here we wrote lucky, R will tell us that it's the class logical. So it's very handy because sometimes you don't know what class an object R has called. So that way we can check. Okay, so let's try it out. Here's a task for you. I want you to create a character object. So remember, that means quotation marks, called my_name that stores your name. And then call my_name to view the stored value. And to do that, all you have to do is simply type my_name and then run that as a line of code. And then I want you to double check the object as a character using the class function. So think about that for a moment and give it a go. And then we're actually going to go over the solution for this one together. So you should be getting something like this. For me, my_name equals Jess. So I created an object with my name. And then I just wrote my_name after that because now my name is in the global environment. R knows what it means. So I ran that. And then look, in the R console, R spat out Jess, my name. And then here I'm saying class, my name. So I'm checking the object class and it's telling me it's a character. So all of that checks out very nicely. Okay, so let's try doing some math with objects. since we are bothering to create all of these values and objects in our global environment, let's see what we can do with them. Please give this one a go. So our challenge is to create a numeric object called myAge that stores your age, then create a numeric object called decade that stores the value 10, and then try adding myAge plus decade. And what you should be seeing is that R knows how to calculate math with objects. So please try that out and make sure that it works as expected. All right, so now that we know about single objects, let's talk about lists of objects. A vector is a list of objects, which is defined with the function c. Very easy to remember this one. It's just a little c, and then we put our list inside of the brackets. It can be a list of factors, numbers, characters, etc., etc. And how we define the vector does depend on class. So we're just going to go over each class to make sure that we understand how this works. As always, numeric is the simplest. To create a list of numerics, we do the name. I'm just calling it num_vector, but again, it can be any name that you want, equals C, and then in the brackets, because remember, C is creating the vector, and then we put every item in the list inside of the brackets, separated by commas. So here I'm creating a list of numbers 7, 8, and 9. Pretty easy. To do integers, we do the same thing, but we need to add the as.integer function first. See here, we're actually nesting our functions. First, R does the outside function, the as.integer, and then it calculates the inside one, which is creating our little function here, creating our list. Okay. For characters, we just use C and then separate the characters out by commas. So make sure that each character has the quotations around it. So here is a list of countries, for example, Ghana, Kenya, and Djibouti. And just separating them all out by commas and making sure that each one has the quotations around it. Now here's a new one. A factor is kind of like a character, but when there's only a few set options, like left, right, or north, south, east, west. So when you're giving every possibility, then you would use a factor. And we differentiate a factor from character with the function factor, which we nest like before with as.integer. And remember, please don't forget the quotations because these are text. And why might a factor be useful instead of a character? Well, let's say we're just looking at comparing people that are left-handed or right-handed. We want R to know that those are the only two options that we're looking at. So we can do quite a few different kinds of analyses with that than if we just have all these different characters, and there could be more added to it. There could be some taken out. So we want R to know it's a complete set and these are the only options. Finally, we have our logicals. This is pretty easy, just a list of true and false that are comma separated. And as always, don't forget to name each of these so they actually go into your global environment. Otherwise, R will just return the list to you. Okay, we can do math with vectors. That's pretty cool. Here's a challenge for you. Please create a numeric vector called my_vector that stores the numbers 1, 2, and 3. And then I would like you to try adding 5 to my_vector. So that's your first challenge, just to do that basic math. So my vector plus 5. And then using the output that you get, so just as an example to think about, I'd like you to do this second challenge. Find a way of performing math on your vector so all the values read exactly 7. And name that vector of 7's 7_vector, then call it. So there's a lot going on here, and we're actually going to go over the solution to this one together. So take a moment and think about it, try and do it yourself, and then we'll go over it. Okay, so the first thing we were asked to do is to just create my vector as a list of 1, 2, and 3. Yes, 1, 2, and 3. That's correct. And then I wanted to add 5 to my vector. So I did this, and then R added 5 to each value. So it gave me 6, 7, and 8, which is pretty cool. So we can do math on the vectors. And then I was tasked with this here. Find a way of performing math on your vector so all values read exactly 7, and name that vector of 7's 7 vector. So this is how I did that. I performed math by timesing 0 and plus 7. So every value was multiplied by 0. So 1 became 0, 2 became 0, 3 became 0, and then I added 7 to each one. So 0 became 7, 0 became 7, and 0 became 7. And then I named it 7 vector and called it, and then R should return 7, 7, 7. Okay, let's talk about vector functions. There are many different functions built into R that work on lists like mean and median to take averages. All you're doing in here is you're replacing X with your vector. So instead of just making X be a single number like 7, it is a list of numbers like 1, 2, 3, or 7, 7, 7. Quartiles give the quartiles, minimum, and maximum value along with mean and median. So this is a really nice one, and we do the quartiles by the function summary. So if we pop summary in there, it'll give the quartiles, minimum, maximum value, and mean and median of your list. Very handy. Sum X, gives the sum of all the values in the vector. So it just adds each number together. It adds 1 plus 2 plus 3, or 7 plus 7 plus 7, whatever it might be. Length is very, very handy. I use this one a lot. And it calculates how many independent items there are in the vector. For example, if you had 10 countries in your list of countries, it would return 10. So it just tells you how many items are in your list. Okay, so those functions were pretty simple with just one argument for a vector. Sample is a little bit more in depth. It takes 2 arguments as an input instead of just 1. This function takes random samples from your numerical vector. The amount of samples it takes is given by the second argument, which is an integer. So that's size here. So essentially, I could put in here my list. So let's say my list was, I don't know, like my numerics. And I had the numerics 1, 2, and 3. And I wanted a sample size of 1. So it should return either 1, 2, or 3, because it's just taking one random number from my list and then returning it to me. And you should notice that every time you call the function, it gives a different result. So I would like you to please try that. Previously, we created my_vector. If you didn't do that, then just create a new my_vector that has some numerics in it. And then I would like you to try taking 2 samples from my_vector. And do this a couple times, like just run the exact same line of code a few times to notice that every time you call the function, it gives a different result. So please try that. Okay, we're gonna talk a little bit more about nesting now. So we talked about it a bit previously. Functions can be placed inside of functions, nesting, which we've done a little bit of already. So for example, this object I'm creating called mean log vector, I tried to color code the brackets a bit to help you see the nesting. So working from the inside out, this command first creates a numeric vector with 3, 4, 7, 0, and 3. Then the log is taken of each value in the vector. So it takes log 3, log 4, log 7, log 0, log 3. Remember that doing math on our vectors. And then finally, it takes the mean of that entire vector. So all of the values that are the output of the logs, it takes the mean of that entire list and stores it in the object mean log vector. So you can see how nesting can be a very useful tool to have in your tool belt. It's actually something you'll probably have to use quite often because it really condenses the code down. So instead of having to do a new line of code for each one of these, okay, define the vector, okay, take the log of the vector, okay, take the mean of the list, and then name it something. Instead of having to do all those on separate lines of code, you can just do it in one condensed, neat function. You just got to keep track of where the brackets are and which functions they're referring to. Okay, and here is your challenge for function nesting. We will go over the solution for this one together. So please read over the challenge and see what you can do. I would like you to please define a new numeric vector with 10 unique numbers. And then in one line of code, take 3 samples from the vector, then take the mean of those samples. And after you've done that, we'll look at the solution together. This is one example solution, and it could be any 10 numbers. I just typed in some random 10 numbers. And then that is called my vector. And then here is that one line of code I was talking about with function nesting. So inside, I have my vector, and 3 is being sampled. So I'm sampling my vector, and I'm taking 3 samples from it. And then I'm taking the mean of that list. So if sample took 5, 3, and 1, then mean would take the mean of 5, 3, and 1. If sample took 9, 1, 2, then it would be taking the mean of 9, 1, 2. Hopefully that makes sense to you. And I do have some more information in the code if you're a little bit stuck on how to logically flow from one step to the next here. Okay, and the final thing that I wanted to just touch on today is predefined values in R. So we add our own values and objects to the global environment, but R has already added a ton to the global environment for us. It just doesn't show them because they're predefined. So for example, if you want to be using pi in your calculations, you don't have to calculate pi each time in an equation. You can just use pi, and R knows what it means. It's like pi already exists in the global environment. R also knows the lowercase letters of the alphabet. If you just type letters, R will return a whole vector of the lowercase letters of the alphabet. And same with uppercase letters is the uppercase letters of the alphabet in a list, in a vector. Month.abb gives a vector of the abbreviated months of the year, Jan, Feb, Mar, etc. And month.name gives the full names of the month of the year in a list, January, February, March. So you can see how those would be really handy just to have them already in so you don't have to manually type out all the months of the year each time you need it. And finally, here's a really handy one. It's 5, and then just a little colon here, and then 16. So what this does is R will calculate a vector of ordered integers between 5 and 16. So it will return 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If you do 1, 2, it'll just return 1, 2. 3, 7, 3, 4, 5, 6, 7. So R can really, really quick and easy make you those lists of ordered integers. Okay, so if you want, go ahead and check these ones out. And there are many, many more online of these predefined values that can make your life a little easier and allow you to move through your code a little quicker. So thank you for checking out the video, and I hope this was useful to you. Have a great day. Bye-bye.